Right, and you've gone to one of the biggest resources that the planet has to offer, looking for some solutions, the oceans. Tell me about that.
We use to say that a strategy is to use what we have enough of: solar, CO2, sand, and oceans. And we are going to produce in what we call the Sahara Forest Project. We are going to bring seawater into the desert, and we work with synergies of different technologies. Concentrated solar power needs cooling. We cannot empty North Africa of fresh water to cool these facilities, so we develop technologies to cool it with seawater. We use the waste heat from this technology into a greenhouse that we have developed that evaporates seawater and condensate out fresh water by cooling the environment. And you get also a humid air outside that get a kind of oasis effect. And this is one of the really optimistic plans we have to create jobs and energy production in the developing countries. And then I hope we get rich countries to buy it to go carbon negative.
Which sounds, revolutionary in a way. So you're bringing the resources from the oceans into the deserts, so two of the biggest areas which we've not exploited, which are perhaps seen as an impediment in many ways. You'll now be harnessing these two areas for the future of the planet's energy needs.
Yeah, I think that's absolutely necessary, and we see a lot of synergies between the different energy technologies. We could, for example, produce biogas of the biomass and feed the turbines in the concentrated solar power during night time, so we get this as a base load, and we get a residue that is very good for fertilizing the desert. So if you do this large scale, it's possible to bind a lot of CO2, and you get biomass both for food and for energy. And if you could use that into power plants with carbon capture and storage, you create large-scale carbon-negative strategies.
And you have two test projects, one coincidentally very strategically placed.
Yeah, we are working now both in Jordania and in Qatar to test and develop this technology. We see large-scale deployment potential, for example, in Egypt, where you have the whole Qattara depression that is under seawater level, and you have very little pumping cost to get the water in, and this could be some of the future solutions. The good thing by thinking this way is that it's an enormous potential for solar and wind, for example, in Africa, but the problems to establish standalone system is that you need to connect up to grid, and you are dependent on many different parameters. If you use this technology, you can store the energy in biomass, and you could have the whole world market independent of big electricity companies. You enable standalone systems, and you at the same time covers the local needs.
Not being able to have these standalone systems in the past, has that been one of the big impediments to using more solar, wind, other renewable energy sources? Because we've often heard it fantastic, great, we'll use more alternative energy sources, but it's not enough. It doesn't supply enough of our energy needs.
The problem is very much of the irregularity of this kind of wind and energy, solar energy and renewable energy. And by combining this with bio, you could create much more stable energy supply, and you are not dependent on big electricity companies. It's a lot of saltwater wells in Africa that is freshwater wells in Africa that is contaminated with salt. Maybe you can use wind or solar to pump this up and run it through the greenhouse technology we are developing and store the energy in the biomass, and Africa get a product of trade. And in my opinion, European Union and other rich countries should look at the CO2 emissions as a bank loan that has created our welfare, and that we should now pay back with an interest. So that's why I work so much with CCS, because I think Europe should go 150% reduction and enable Africa and other developing countries for a better growth.
Is it possible at this stage to talk about timetables, timescales, when these kind of projects could be benefiting vast percentages of the world's population?
I hope that we, during the next 3-4 years, will be able to test and modify and develop the test centers. And then we need to go back, because one thing is to build one of a kind or two of a kind. Then we need to redesign it, because we really would like to large-scale deploy it. So up towards 2020, I hope that we will enable large-scale mass production binding CO2 into the biomass.